Okay, here we have few variables, that is dummy variables, GDP, investment, and finally the rate of literacy. So we have four variables, and I am opening all the variables as a group. So this is my all the variables you can see. So the first one is dummy, GDP, investment, and literacy. And the data start from 1980 until 2010. That is our data from 1980 until 2010. And we have four variables: the dummy, excuse me, GDP, investment, and the rate of literacy. Okay, these data I have taken from a country like Maria Land. So actually Maria Land is a hypothetical country. Okay, from there I have collected data, and but here I have put one variable which is dummy. You can see from here, from the 1980 until 1999, the dummy I have taken all zero. Dummy I have taken 0 from 1980 until 1999. But from the year 2000 until 2010, the dummy variable is 1 that I have chosen. So what does mean by 0 and what does mean by 1? Okay, from 1980 until 1999, Maria Land was not a welfare state. From 1980 until 1999, Maria Land was not a welfare state. So the country was not a welfare state, which is 0. What does mean by 0? Dummy variable, meaning that the country is not a welfare state. That is all 0. Okay, but after 2000, Maria Land become welfare state country. That means Maria Land convert into welfare state by constitutions, and that start from 2000 until 2010. And here I have put all 1. You can see 1. 1 means welfare state here. So I am telling again, 0 means not welfare state and 1 means welfare state. Okay, and what is our objective of this model? The objective is that welfare state that Maria Land has become has a positive impact on the literacy rate of Maria Land. I'm telling again our objective. The objective is that welfare state that Maria land has become has a positive impact on the rate of literacy of Maria land. That we want to check. That we want to check whether welfare state has a positive impact on the rate of literacy or not. That is the objective. And if the dummy variable become significant and the coefficient of dummy variable become positive, then only we can say that welfare state, which is Maria land, has a positive impact on the rate of literacy. I am telling again, if our dummy variable becomes significant and if the coefficient of dummy variable become positive, meaning that welfare state has a positive impact on the rate of literacy of Maria land. Okay, and here actually we shall develop, our target is to develop error correction model gradually. But first we develop the unit root testing. That means whether our GDP, investment and literacy, whether these three variables have unit root or not. That we want to check. Okay, but here we have no plan to check it. We have no plan to check it. We just assume that the GDP, investment and literacy, these three variables become stationary after first difference. That means at a level they are non-stationary. But when I convert this variable into first difference, they become stationary. That we just assume, right? And when this thing happen, only then we can run the Johanson cointegration test. So I'm telling, when we can run Johanson cointegration test, we can run the Johanson test of cointegration when the variables are integrated in the same order. Only then we can run Johanson test of cointegrations. And here we have assumed that all the three variables become stationary after first difference. So they are integrated of the same order. So now we can run the Johanson test of cointegration. How to run? I go to quick, then group statistics, then Johanson cointegration test, right? I choose from here. Okay, so first I write literacy, then I write GDP, then I write investment, these three variables. But these three variables are non-stationary right now. That we assume that these three variables are non-stationary right now, but if I convert them into first difference, they will become stationary. Okay, then I run the model, the Johanson model, and here I choose 3, and lag I choose suppose 4. I choose 4, right? 4 lags. Then I run the model. Okay. So this is the outcome. Literacy, investment, right? And here our trace statistics, right? And also my max eigen statistics. So first we check this one, trace statistics, right? Okay. And it is our null hypothesis, number of cointegrated equation. Okay, suppose the null hypothesis is none. None means there is no cointegrating equation. So can I reject this null hypothesis? Yes, because the p-value is less than 5%. How much is the p-value? 0.43%, which is less than 5%. So when the p-value is less than 5%, we can reject null hypothesis. Okay. And also we can check here, you can see that trace statistics is more than critical value. So what is the guideline? The guideline is that if the test statistics is more than critical value, we normally reject null hypothesis. And here 38.16 is bigger than 29.79%. So we can reject null hypothesis, which is this one. Okay, then what about this null hypothesis? At most one cointegrated equation. Can I reject this one? No. Why? The p-value is 29.86%, which is more than 5%. So we cannot reject our null hypothesis. And what is the null hypothesis? The null hypothesis is there is at most one cointegrated equation. And also we can see from here that trace statistics 9.777 is smaller than critical value 15.94. So we also cannot reject null hypothesis, meaning that we accept null hypothesis. And what is it? There is at most one cointegrated equations. And you can see from here the decision. Trace test indicates one cointegrated equation at 5% level. Why 5%? It is from here, critical value, right? At 5% level. Okay, then we talk about max eigen statistics. So this one is the another statistics. And what is our null hypothesis? There is no cointegrated equation. Can I reject? Yes, because the p-value is less than 5%. so we can reject null hypothesis. And also from here, the max eigenstatistics is bigger than critical value, so we can also reject null hypothesis. Then what about this one? Second one, the null hypothesis is there is at most one cointegrated equation. Can I reject it? No, because the p-value is 22.75%, which is more than 5%. So we cannot reject null hypothesis, meaning that there is at most one cointegrated equations. And we can also see from here, you can see max eigenstatistics is less than critical value. So what is the guideline? The guideline is when the test statistics is smaller than critical value, we cannot reject null hypothesis. Rather, we accept null hypothesis. So, what is the decision? Max eigenvalue test indicates one cointegrated equation at 5% level. So, both the test statistics and max eigenstatistics is telling that there is one cointegrated equation. What does it mean? It means that our three variables such as the investment, GDP, and the rate of literacy are cointegrated, or our three variables have long run associationship. Okay, so and when the variables are cointegrated, then we can run the VECM model. So what is the guideline? If the variables are cointegrated, we can easily run vector error correction model, and that we shall do now after a while.